Have you ever, really looked at the fabric of your shirt or your jeans and just wondered how? How do all those thousands of tiny individual threads come together to make something so strong? Well, it's not magic. It's an incredible high-speed performance, a mechanical ballet. So, here's how we're going to break down this mechanical marvel. First, we'll cover the basics of going from thread to fabric. Then, we'll get into the three essential moves: shedding, picking, and the beat up. After that, we'll see what actually powers this whole dance. And finally, we'll put it all together to see the entire system in action. All right, let's kick things off with our first section. We're going to start to unravel the hidden complexity that's, believe it or not, in every single piece of fabric we touch. And really, this is the big question we're tackling today, isn't it? How does the machine take what is basically a chaotic jumble of threads and turn it into something so perfectly ordered, so strong, and so useful? Well, it all boils down to one process: weaving. And at its heart, the idea is beautifully simple. You're just interlacing two sets of threads. You have the lengthwise threads, called the warp, which are stretched tight. They're the backbone of the fabric. And then you have the crosswise thread, the weft, which gets woven in and out. That simple grid is what gives the fabric all its strength. Now, to do this with a machine, and to do it super fast, a loom just repeats three fundamental moves over and over again. First, there's shedding, which is all about creating a path. Second is picking, where the thread is inserted. And third is the beat up, which locks it all down. Shed, pick, beat up. That is the rhythm of the loom. Okay, let's really dig into that first move, shedding. And yeah, the name kind of gives it away. This is all about opening up a path for that weft thread to travel through. So what is shedding exactly? Well, it's the process where some of those warp threads get lifted up while others get pushed down. This is done with these frames called heelds, and the action creates this neat little triangular opening right between the threads. We call that opening the shed. And honestly, without that clean separation, fast-paced weaving would be totally impossible. And what's so cool here is how simple the motion really is. One set of threads goes up, another set goes down, and boom, you've got a clear, open path right through the middle. The loom is literally creating a temporary tunnel for the next thread, setting the stage for the entire pattern of the fabric. Now for the second act, and this is probably the most dramatic part of the whole show: picking. This is the moment of pure speed, where the weft thread is blasted across the entire loom. So, picking is simply the act of shooting that weft thread through the shed that we just created. For a long time, this was done by launching a wooden part called a shuttle, which carries the yarn across the loom at, and I mean this, in incredibly high speed. But not all picking is the same. There's a real engineering trade-off that has to be made. A more gentle picking action is easier to maintain and doesn't beat up the machine as much. But a harsh picking action, while maybe faster, is way harder to adjust, and it puts a ton of stress on all the components. It's this constant balancing act between speed and durability. And timing? Oh, timing is everything. This quote from our source material just says it all. An earlier pick gives loss of power, as the shed is not sufficiently open for the entry of the shuttle. Think about that. If you're off by even a fraction of a second, the shuttle snags, the yarn breaks, and the whole thing fails. It's all about perfect synchronization. And we are talking about some serious force here. The shuttle isn't just gliding across, it's being fired with immense power. It needs to accelerate massively to get across the entire width of the loom in the blink of an eye. Seriously, imagine trying to throw a baseball through a tiny window that's slamming shut hundreds of times a minute. That's the kind of power and precision we're dealing with. Okay, so our weft thread has flown across the loom. It made its journey, but it's just hanging out there, loosely. What's next? It's time for the final push, the beat up. This is the move that locks that new thread right into place. The beat up is this motion where a device that looks a lot like a comb, it's called a reed, swings forward and slams that new weft thread against the fell. And the fell is just the technical name for the edge of the fabric you've already made. This isn't a gentle nudge, it's a forceful shove that puts the new thread exactly where it needs to be. And I mean it, this is not a gentle tap. It's a really powerful, repetitive slam that makes sure every single thread is packed in tight and perfectly aligned. This is the motion that turns a loose web of strings into a dense, strong material. It's what gives fabric its final structure and strength. Without a good beat-up, you just have a flimsy net. Okay, so we've got our 3 core moves: shed, pick, beat up. But what's making it all happen? What's the engine behind this whole intricate dance? Let's zoom out a bit and look at the orchestra of components that powers the whole show. Yeah, to make all this happen, you need a whole symphony of parts working together. You've got belt drives, chain drives, gears, cams, and tappets for that perfect timing, clutches to kick everything into gear, and brakes to stop it all on a dime. Every single one is playing its part. Let's just look at the big 3 here for a second. Belts, they're fantastic for moving power over distances, and they're cheap and easy to install. Chains give you that solid, no-slip connection with crazy high efficiency. And then you have gears. They're the masters of precision, turning circular motion into a straight line exactly when you need it. Each one has a critical job to do. But all that power is useless without control, right? And these 2 systems are absolutely critical. The clutch is basically the on switch, engaging the motor to get the whole ballet started. And maybe even more important is the brake. It can stop the entire loom instantly the second a single thread breaks. That prevents one tiny mistake from ruining yards and yards of fabric. So now that we've met all the players and we know all the moves, let's put it all together. Let's watch this perfectly woven system, this mechanical ballet, in action. One single cycle happens so fast, you can barely see it. First, the shut opens up. Instantly, the picking motion launches the shuttle, and it flies across. Right after, the beat-up slams the new thread into place. And then, the whole thing repeats. Instantly, perfectly, hundreds of times every single minute. So, when you boil it all down, that's what's happening. Hundreds of perfectly synchronized movements, all timed down to the millisecond, are working together to transform thousands of flimsy individual threads into one strong, unified piece of fabric. It's a stunning piece of mechanical choreography. The very fabric of our lives is quite literally woven by these machines of incredible ingenuity. And it really makes you wonder, doesn't it? What other everyday marvels of engineering, of physics, are hiding in plain sight, just waiting for us to take a closer look?